All right, let's take a look at the test. Let's go over question one. Question one, we are using the decay equation, y equals a parenthesis 1 minus r to the t, the ART formula. It says rate of decrease. We know it's decreased because the number inside the parenthesis is 0.92. Again, we always start with 1 inside the parenthesis. So the question is, what are we taking away from 1 to get to 0.92, which would be 92 cents? And that would be 8 cents. So we're taking away 0.08. So we need to take that decimal, move that decimal twice, and that would be 8%. And 8% for question one is A. Question two, which one is exponential decay? Exponential decay means we are decreasing, and we need to be dividing. This is the key word here, half. If you're doing half of something, that means either you're dividing by 2 or you're timesing by a half. Remember, exponential means that we're multiplying or dividing. This first problem, you're minusing 10 each time. This second one, you're minusing 1 each time. This third one, you're minusing 1 each time. So the answer would be D. Question 3. At the beginning of an experiment, there are 100 bacteria. How many will you have at the end of 6 hours? So at the beginning of the experiment, there has been no time. So that's 0 hours, and that would be 100. It says that we are doubling. So when we get to hour 1, that'd be 200. Hour 2 would be 400, since we're timesing by 2. 3 would be 800. 4 would be 1600. We come over here for more room. 5 then would be 3200. And then 6 at 6 hour would be 6400. And 6400 happens to be D. Question 4. Which one of the following statements is true? Again, the A is the initial value. So when we look at C, C says when the population was 4,800 when the data began. Yep, A is always the initial value, so the answer is C. The rate is not 102%. Remember, it's 1 plus, so the rate would actually be 2%. So it's not A. Maximum of 4,800 people. There is no maximum of this. We'd have to actually plug in something for T to find out what the answer would be for that. So it's not B. And then grew by 102. No, it's growing at a different rate since it's exponential each year. So the answer is C. Move on to question 5. Question 5, we have 2 different graphs that are here. G of X eventually is going to be more than, it's exponentially increasing, than F of X. So G of X will eventually be more, so G of X eventually exceeds F of X. G of X eventually exceeds, so it's either A or B. It's not going to be C because F of X is going to be smaller. It's not going to be D because F of X is smaller. So if it's A, because the rate of change of F of X increases, no, F of X is linear, so that means its rate of change is always going to be the same. If we look at B, G of X is going to be more than because its rate of change increases. Yep, that's why it's going up on a curve, because its rate of change is increasing, so the answer for this one is going to be B. Question 6. This one we really have to look at. We have 2 different functions, F of X and G of X. F of X is X to the 5th, that's this one. G of X is 5 to the X, that's this one. F of X is going to exceed for all values. Well, as of now, g of x in the first one is bigger. 5 is bigger than 1, but then when you get down to 2, 32 is bigger than 25. So we can't say f of x or g of x is bigger for all values. That means we have to eventually figure out greater than 5. So what if we use x is equal to 6? So if x is equal to 6 now, we're going to come over and use Desmos. So the first one then would be 6 to the 5th. And then for g of x, it would be 5 to the 6th. So 6 to the 5th. 6 to the 5th. Get our exponent. This is going to be 7,776. So this one is 7776. If we do 5 to the 6th, 5 to the 6th, that's going to be 15,625. This one is 15,000. We already know that 15,000 is going to be more. It doesn't even matter what these other numbers are. And that's g to the x. So it looks like the answer is going to be D. Let's go to question 7. We have our two functions below. Which statement is true? Looking at rate of change. For f of x, rate of change is going to be the slope, the value in front of the x, so rate of change is 2. G of x is over here. As we go from 6 to 3 and 3 to 0, this is a minus 3. Again, if it's either A or B, rate of change means which value is bigger, which one is increasing or decreasing at a higher rate. 3 is going to be more. 3 is going to be decreasing at a quicker rate than 2. So negative 3 or 3 over here is g of x. So B would be the answer. G of x has a greater rate of change. Question 8. So this again is simply knowing what our formula is and what everything stands for. This formula is y equals a times b to the x. A is the initial value, b is the growth rate, x is the amount of time. So if this is our equation here, initially there were 4 bacteria. No, the initial number is the number outside the parentheses. So there's initially 20, so that's not it. Initially there were 80. No, we just said again that A is the initial amount, 20. The number of bacteria in the petri dish increases by 20 every hour. No, it's going to double every hour. I'm sorry, it's going to increase by 4 every hour, so that's not right. Right, the number of bacteria in the petri dish quadruples. Yep, quadruple means you times by 4. That's the number inside the parenthesis. Double would mean times 2. Triple would mean times 3. Quadruple means times 4, so the answer is D. Let's move on to question 9. Which statement best describes the model? So again, we're using that same model that we used earlier, where it's y equals a 1 plus or minus, and this number right here is more than 1, so that means we did 1 plus r to the x or to the t. This value is the growth value, so increasing, no, but we're multiplying by, so it's not increasing by, that would imply we're adding. The amount is increasing by 13 or 15, so we start with 1, and again, you're ending with 1.13, that means you start with $1, and you're ending with $1.13. How much did you add? You added 0.13. And again, if you take 0.13 and turn it into a percent, that decimal is going to come over twice. So that would be 13%. And that answer is C. Let's go to question 10. For this problem here, we're just going to graph them on Desmos. The answer is going to be D, so I'm just going to type that in. f of x. Desmos does not like f of x, so we're going to do y equals negative 0.25, negative 0.25, parentheses 0.5 to the x, parentheses 0.5, and we need our exponent to the x. And there is the graph, the same one that we have here. So the answer is going to be D. Let's go to question 11. Question 11 is located here. For this one's a bit tricky. We're going to need to write some equations. Option 1, $7 for each hour she works. So if we're going to graph that, that would just simply be 7x, making $7 an hour. So however many hours you're working, you put that in for x. So if you're working 2 hours, it'd be 2 times 7. If you're working 10 hours, it'd be 10 times 7. Our second one then, for the first hour, you're getting 25 cents, and then it's doubled. So 25 cents is the initial. We're then doubling, that's the growth or factor rate, so 2. We don't know how long worked for. So when would option 2 have the higher hourly wage? So once we graph these, we need to see once option 2, once this one is more. So we go back to Desmos, our first one, y equals 7x. Y equals 7x. There's the linear line for that one. Our second one that we came up with, 0.25 times 2 to the x. Y equals 0.25 times 2, it doubles to the x. And there's that one. Need to see where they cross or intersect. There's the value there. So at 7.7, what are we dealing with here? We're dealing with hours, so that's when they're equal. We need to find out when the red one is finally going to be more. And once that red one is finally more, if I can get over to the red one, our first number greater than 7 is going to be 8, and it is right there, 8:56. So 8 is the x, so it would be 8 hours. The answer is C. That is the first time that that one will be more than at 8 hours. Let's go to question 12. Question 12, which table represents an exponential function? Remember that exponential means that we're either multiplying or dividing by the same value every time. When we look at A, 3, 9, 27, this is a times 3 pattern, so it's A. B, you are adding by 3, so that's linear, not what we're looking for. I don't know what the pattern is in C. This is also, it looks like a plus 3 pattern. So exponential, the only one that's multiplying or dividing is A. Question 13. Another one using our formula. For this one, population is increasing. So since our population is increasing, we're using y equals, it's our growth, arts, A, 1 plus r to the t, or in this case, we're using to the x. It says increasing, so that means the number inside the parenthesis has to be more than 1. This number inside the parenthesis is less than 1. That's less than 1. So it's one of these two. So we have the rate, 3.1%. We need to change that into a decimal. That decimal is going to come over twice, so it's 0.031, and we're going to add that to 1. So that means when we add this to 1, we're going to get 1.031, so the answer is C. Let's go to question 14. Very similar here, same type of question. This question is saying that it's decreasing. So since we're decreasing, this is the art formula again. But since we're decreasing, it's minus. So that means since we're decreasing, the number inside the parentheses has to be less than 1. So that means it cannot be C, cannot be D. 1.11 is more than 1. 1.88 is more than 1, so it can't be that. Again, here's our percent, 11.25. That decimal's got to move twice to the left, 1, 2. So that turns into 0.1125. So that means we're taking 1 minus that amount. And 1 minus that amount is going to give us 0.8875. So the answer for this one is B. And our last question, question 15. What is the positive integer x when f of x will exceed the value of g of x? We're going to go into Desmos again. Y equals 2x. Y equals 2x. For our second equation, y equals 16 minus 2x. Y equals 16 minus 2x. Want to find out where they cross? Let's go back home. They cross right here, it looks like. That's at 4, 8. What does our question say? For what positive value x will the value, and I actually didn't make this an exponent, so sorry about that. That should be 2 to the x. There we go. Nope, that's still not right. 2 to the x. There we go. So that's where they cross. We're looking for the first time, the first value in f of x, that is the curved one, is going to be more than g of x, so the first whole number. So here's where they're equal. The curved one is the red one. We need to find the next whole number that's going to be on the red, and I actually need to scroll up a little bit more, and that value will be, I need to scroll up a little bit more, just going to miss it. That value should be right here. And there it is. It's 4, 416. So it's 4. 4, the answer is B. Hope that helps. And that is how you get the answers for the test.